Welcome to part three of doing the same things over and over and over and over and over and over. Okay. Okay. So we're going to convert grams to atoms of silver. So we got to do two steps. There is no step to go from grams to atoms, but we can go from grams to moles and then from moles to atoms. And I know that 1 mole contains 6.02 times 10 to the 23rd atoms. And I know that 1 mole of silver contains 108 grams of silver. And I know that I'm starting out with 2.5 grams of silver. Oh, sorry. Yeah, silver. All right, so we do 2.5 divided by 108 equals 0.023 moles. 0.023 moles of silver. So I'm going to begin with 0.023 moles of silver times 6.02, parentheses, 6.02 times 10 to the 23rd, close parentheses. I just did my answer, so that many moles times 6.02 times 10 to the 23rd equals 1.39 times 10 to the 22nd atoms, or molecules, or whatever you want to call it. 39 times 10 to the 22nd molecules, atoms, whatever. 36 grams of HNO3 to molecules. So again, we got to do it in two steps. 36 grams of HNO3, grams HNO3, mole HNO3. And that answer is going to go to the top left of here where we do moles, HNO3, mole, HNO3, molecules, HNO3. And I know that in 1 mole there are 6.02 times 10 to the 23rd. Also know that in 1 mole there are nitrogen 14 plus 3 times 16 plus 1. There are 63. So 36 divided by 63, enter, which is 0.57 moles, times parentheses 6.02 times 10 to the 23rd, enter, and this all equals 3.44 times 10 to the 23rd molecules. Molecules. 44 times 10 to the 23rd molecules. And down we go. Alright, atoms to grams, okay. Iron, 2.22 times 10 to the 23rd atoms of iron. Atoms of iron. 1 mole of iron. 6.02 times 10 to the 23rd. That gives us moles of iron. Mole of iron. Grams of iron. And in 1 mole there are 55.8 grams. Okay. Parentheses 2.22 times 10 to the 23rd divided by, open parentheses, 6.2 times 10 to the 23rd gives us 0.36 moles. Gives us 20.57 grams of iron. 20.57 grams of iron. So what I did there is I converted to moles, then that answer went into here, and then I converted to grams, multiplied it times that. There it is. Okay. Did you see any of that? Yeah, went from atoms to moles, moles to grams. So hard to keep everything on the page. Okay. I'm going to turn this upside down. Okay, molecules to grams. Okay. Again, 2 steps. Times 10 to the 20th. Molecules. Molecules. Everything has to go through moles. In 1 mole, there are 6.02 times 10 to the 23rd molecules. Then we're going to go from moles, moles to grams. CO2 in 1 mole. And that is what? Yeah, 44 grams. Okay, so then 4.0 times 10 to the 20th divided by 6.02 times 10 to the, oops, 23rd, 0.0006 moles, 0.029 grams of CO2. 0.029 grams CO2. Okay. Empirical formulas. Empirical formulas are just a formula that you've factored out. You've taken the greatest common factor out. So here it would be 4, so this would be CH. Here it would be 2, so this would be CH. So they have the same empirical formula as what they're trying to get at. Here I'm going to factor out a 2. It's going to give me C4, H5, N2, O. Once you get 1 of anything in the formula, you're done. You can't factor anything. You can't factor a 1 out. So once you get to 1 atom of something, that's it. You're done. All right, C6H12O6. So I'm going to factor a 6 out. So I have CH2O. This is already an empirical formula, so I've identified him. Here I'm going to factor a 3 out. CH2O. All 3 have the same empirical formula. This is the one that started as an. Okay, now we got some lengthy things to do. Okay, so when doing and actually I'm not a big fan of 18 because it gives you a partial, you get a 1.33 mole fraction. But anyway, let's do 19. We're going to do 40% carbon, 4.58% hydrogen, and make sure that you specify. That way you know that this, whatever problem I'm working down here, is the subscript for carbon. And here it's hydrogen, and over here it's going to be oxygen. 53.29% oxygen. First thing I do is Wally Kazam. Hang on, using my and make them into grams. Second thing I do is make them into moles. So 40 grams of carbon, grams of carbon. There are 12 grams of carbon and 1 mole of carbon. 4.58 grams of hydrogen, 1 gram of hydrogen, and 1 mole of hydrogen. So that is 4.58 moles of hydrogen. 3.29 grams of oxygen. 1 mole of oxygen, there are 16 grams of oxygen. Divided by 16 equals 3.33 moles of oxygen. 40 divided by 12, 3.33 moles of carbon, 4.58. Oh, this is the one with the partial. Okay, so step one, converted it to grams. Then I converted grams to moles, and then I divide by the lowest mole total. Well, here, obviously, it's 1 and 1. Here, if I divide by 3.33, I get 1.3. Now, I can't leave that. It's actually 1.37, blah, blah, blah. But if I have tenths difference, then I can't just leave that. I actually did the wrong one. 19 is the one I wouldn't want you to do. 18 would be the one I want you to do. But if I multiply that times 3, then I get 4 here, 3 here, 3 here, C3, H4, O3. That's not the one I would prefer you do, but whatever. Okay. Let's do 18. 40.92% carbon, 4.58% hydrogen, 54.5% oxygen.